Welcome to the video for Lecture 12, Section 1 for BBE 4023, Process Control and Instrumentation. This video introduces you to more block diagram elements and block diagram algebra. You have seen numerous block diagrams already, but now we are going to discuss how you can manipulate them to take complex block diagrams with all of the elements and consolidate it into a single overall transfer function. This builds on the process covered in Section 11 of the course packet when we combine multiple first-order processes in series into a single transfer function. This section describes the process figuratively. Block diagram elements are simple pictorial representation of all of the elements of a closed-loop process control system. Block diagrams illustrate all of the key system components and their interrelations. Block diagrams can be used to show the material flows and information flows, and much of the block diagram is based on the concept of a transfer function, which has an input function x of s in this slide and an output function y sub s in this slide, and are related based on the function g sub s. Here is a simple pictorial representation of a closed-loop process. Some processes will have more blocks and elements. Some will be simpler. Each block represents a device which we will describe with a transfer function. Also note that the flow of material and information is unidirectional, which means that each line has an arrow at only one end. Material and information can go any direction, but each line or connection can only have one arrow. These block diagrams are similar to maps and circuit diagrams. Once you know how to read them, you can begin to understand all of the important parts of the process and how they interact. Our goal with this section of the course is to collapse the block diagram with all of the individual elements down into a single block with the overall transfer function. Here are two block diagram elements. The symbol is a circle with an X in the middle of the circle. In general terms, they are both called summing points, but we will commonly use both the term comparator and summing point. Please note that within the comparator there is a plus sign by the R input and a negative sign by the B input. So the comparator is used to calculate the difference, R minus B. So that is what is written on the comparator output arrow. The summing point on the right has two plus signs within the circle, indicating that the two inputs N and M are summed and the output is N plus M. Summing points can have more than two inputs. When you look at summing points, make sure that you check the sign to identify comparators. This slide is a review. It shows transfer functions as the ratio of the output function over the input function and the different ways the transfer functions can be written. Now let's start talking about block diagram algebra. First is combining blocks in series. We start with two blocks or transfer functions, G1 and G2, that are in series. We can combine them into one block with the two transfer functions, G1 times G2. The input function is x and the output function is z. The rest of the slide shows the process for combining transfer functions in series as we did in Section 11 of the course packet. We write G2 is equal to z over y and G1 is equal to y over x. When we multiply them together and simplify, G2 times G1 is equal to z over x. As we simplify block diagrams, it is easier if you start with a transfer function from the outlet end. Notice that I wrote G2 first. Starting with the transfer function at the outlet end will usually make writing the block diagram algebra terms easier. So blocks and transfer functions in series are multiplied together. This slide shows blocks and transfer functions in parallel. This means that the input function x is an input to both the transfer function g1 and the transfer function g2. The two outputs are summed in a summing point to produce the combined output y. Pictorially, the transfer functions in parallel are summed to produce the output function y. In equation form, again starting from the output, y is the sum of x times g plus x times g2. When we algebraically simplify the expression to write it as the output function y over the input function x, we find that that is equal to the transfer function g1 plus the transfer function g2. Later in the semester, we will find it convenient to be able to move the summing point. At this point, all I want to do is explain how the block diagram figures and the block diagram algebra equations are related. So by looking at the block diagram to the left and starting at the output z, we can write that x times g plus y times g equals z. Then algebraically, we can pull out the g term and get that z equals g times x plus y. Now looking at the figure to the right, again starting with the output z, we can write that x plus y times g equals z. So this means that the two figures are equivalent. I prefer working with the algebraic equations, but some people prefer the block diagrams. Here is another example where the summing point is moved from the right of the transfer function g to the left side. In this case, we add another transfer function, 1 over g. Looking at the figure on the left, we can write z equals y plus x times g. This is the impact of the summing point. Now if we look at the second figure, the one on the right side of the slide, we can write, starting at the outlet z, that z equals g times x plus y times 1 over g. If we multiply through by g, we get the same expression we had for the figure on the left side, so they are equivalent block diagrams. We will not be using these diagrams that move the summing point much, but we will use them later with a couple of examples, and this is the best place to introduce them. This brings me to the end of the Lecture 12 Section 1 video. Write down any questions you may have and bring them up in class.